Hello, I'm Barbara Tharp.
And I'm Deanne Erdman. We're from Baylor College of Medicine Center for Educational Outreach.
And we're here today to introduce a new unit to you, the science of microbes. We're going to begin the unit with what do you know about microbes? It's the first activity. The activity is aligned with the National Science Education Standards for Inquiry in Life Science.
And during this lesson, the first thing that we're going to do is to start out with a pre-assessment, which is always a good idea to find out, exactly what your students know, and that gives you a better indication of what direction you want to take them. During this lesson, they're going to learn about the prevalence of microbes in our world, and then we're also
going to begin a concept map that will help students visualize and link important topics.
Okay, so before we begin, we want to talk to you about some materials, and we know that anytime you're working with students in the lab, that lab management can be a problem, so you want to
make sure that you plan ahead. You want to make sure that you, if possible, you can work in groups of 4, and the groups of 4 need to have individual jobs so that everyone understands what they're doing to begin with. One of them needs to be the materials manager, and they would get the materials, so you'll need to have the materials ready to go, and also you'll want to have photocopies of the pretest. To set up the materials tray, let's look at what we have on the tray.
And and I was noticing, Barbara, this seems like a great way to manage things, is to have some kind of tray or basket so that you can send that materials manager, and also it's an easy way to get everything back again as well.
Exactly, an easy way for them to just come and pick it up. It takes a little bit of planning on your part, but it's worth the effort. For this activity, Activity 1, we're going to look at the materials that we need, and we're going to need Post-it notes, some paper clips, hand lens, a stopwatch, pennies, and any other small items that you might want to have them look at, as well as markers. And we also will need glow germ powder.
And you can buy this in a kit, but really once you get the kit, the only thing that we've used out of it is the powder. We've actually gotten a larger ultraviolet light, and the fluid, when we tried it, it was really pretty messy. I think the powder's messy enough. And to prepare this ahead of time, what we did was to take a liter bottle and fill it with water, put it into a Ziploc plastic bag with the glow powder, and shake it up so that you get it on there. When you get ready to use it, you're going to kind of dust it off as best you can, and it's a little bit messy. And what Barbara and I frequently have done is just to, we'll say something about, oh my gosh, as we're pulling these out, this must have been in with the flour, and it's okay, and we just sort of dust it off, and we don't worry about it from there. So we just kind of make light of it. But you do want a pretty good coating of the powder on the outside.
Right.
This is actually what's going to fluoresce under the ultraviolet light.
And also, you do need to have the ultraviolet light. This is just like you can get it from a party store somewhere, relatively inexpensive, but really important to the whole activity.
All right. So an important thing with any lab activity is to always follow safety instructions. And even if there's something where it's a very simple, straightforward activity, and the worst thing that can happen is a kid could spill a little bit of water on the floor and somebody slip. You still want to always make them safety conscious. It's much better to be a little bit overzealous in your instructions for safety than it is to have somebody that's injured. And these are just some good standard safety rules. I would always check with your district and with your school and follow those instructions. But definitely the first one, follow all instructions, is very important. Begin the investigation only when instruction. How many times have you had kids that as soon as you had the materials out on the table, they're already starting?
They're right.
And of course, not tasting or smelling unknown substances, and reporting accidents and spills immediately. And we always want to wash our hands after the investigation.
And use goggles when necessary.
Oh, absolutely.
Definitely.
All right. So what's next?
Well, I think we'll start with the pre-assessment. The pre-assessment, what we want to do is just pass this out. This will be an individual activity that each student will do it by themselves. Make sure they understand that this is not for a grade. This is just a pre-assessment so that they'll know more about what they know and possibly where they're going with this unit. Once they've finished it, collect those, and then what you want to do is ask them, what do you know about microbes? And when they're talking about what do you know about microbes, let them brainstorm things that they might know. You might want to record any questions they had from the test. It's a good time to find out a lot more about what they know. You might prompt them with things like, what size are they? Do they know what size they are? Have any idea? Do they know if they're helpful or harmful? If they're plentiful or rare? And are microbes necessary or non-essential? What do they know about it? And if they have any really overarching questions, you might record those questions to revisit later.
Right, and as Barbara was saying, you certainly want to guide students. You want to correct some misconceptions, but it's not a time to kind of do the old stand and deliver kind of teaching where you tell students every single thing that they're getting ready to find out. All right, so to begin with, we're going to work with the metric system a little bit.
Okay, we're going to ask them, pass out a paperclip to every student. And with the paperclip, we're going to ask each student, how much do you think one paperclip might weigh? And this is a good time. A lot of students are not familiar or don't remember or are not real conversant with the metric system, so this might be a good time to possibly review the metric system. Once you get past that, hopefully explain that the one paperclip is 1 gram. And if this is 1 gram, then what might the penny be? This would be a nice time for you to introduce some kind of like a triple beam balance or some kind of a scale. So you can take the scale out and ask them to measure it and estimate how much they think based on what the paperclip weighs, what the penny might weigh. And the penny weighs about 2.5 grams. This is a nice time when they get into measuring to have them measure other things. Maybe they want to measure a binder clip or whatever things you have around that you might want them to measure, just to get more familiar with measuring. And once they've done that, you're going to ask them, if looking at everything else, how much do you think this bottle might weigh? And with that in mind, you want each student, get this out of the way, you'd like each student to take a Post-it note. After they estimate how much do you think that weighs, the bottle and the fluid inside, and have them write it like large enough that you can post it. And so they write down about what they think, how many grams they think the bottle full of water weighs.
And as they're passing this bottle around, make sure that you have them pass it to one another, to feel it, because you want everyone to come in contact with this bottle and to get a feel for the weight. And then after that, we're going to ask the students to come up and do this on the board, and we'll try to just give you a little simulation of what's going on. Let's say, for example, one student said that they thought it weighed 46 grams. So where would you put that, Barbara?
Way over there.
So 46 grams right here. And then I have one that's 500.
So it would obviously have to be way over here. And this is not going to be to scale, but this will give you an idea.
900.
900 would be way over here.
Oh, we got 1,000. You're going to have to adjust.
Okay, so then that's when we would go.
Another one for 1,000.
Let's move the 40 way off to the very far edge, just as far as you can go.
Good.
Okay.
And then 100.
Okay, and that would go over here somewhere.
Right.
And
1,000.
Another one. So we're making as you can tell, we're making a bar graph at this point in time.
And then 1,000.
Okay.
All right. So you get the idea of what we're doing here, and you can also see from the slide that goes along with this video that you've actually created a graph so that students can begin to see a pattern. And it may turn out where the majority of your students actually know that this is a liter bottle, which weighs about 1,000 grams. Okay. But it could be that kids are just totally unfamiliar with that measurement.
Definitely, it's a good way to start it. And and while you're at it, you might want to talk about the fact that 46 would be way off the scale, so we would want to have it way down at the far end. And if we talked about outliers, it would be an outlier because it's so far off the scale of 1,000 and 500 and 100. You could also at this time mention other. You could mention the mode, the mean, the median, outliers, all these things with this graphing if you wanted to connect the math and the science in a really significant way.
Okay, great. So it's a great way to combine a little bit of practice with graphing as well.
Okay, once everybody has given their estimate, we've graphed it, we've talked about the numbers, then I want everyone to look at their hands. And when they examine their hands, because they've all handled this and they think it's just flour at that point in time, then they all should have some of the glow germ on their hands. So at this point in time, this would be a surprise for them. We'll take them and have their hands and put them under the light. And when you put them under the light, you see the pattern where you can see all the little dots of glow germ. And this is a model, obviously, a model for how easily microbes spread by contact. Now, that's not the only way microbes spread, but it's one of the ways, and this is a nice way to kind of introduce the fact that they're very small, can't hardly be seen, and they're spreading. Okay, or they can spread.
Right, and one other thing that we forgot to mention is the significance of the liter bottle is that the 1,000 grams is approximately the mass of the microbes that you find in and on your body. So we have quite an ecosystem going here. And obviously, since most of us are healthy, what would you think about them all being harmful?
And that's a good time for the kids to realize, wow, if we have that many in us and on us and we're still alive and basically well, there must be a lot of helpful microbes.
Right. Okay, and one thing with the film, we kind of introduced you ahead of time to what the glow germ powder was, but of course that's a surprise for the students. But you would want to do this so that they kind of discovered it along the way.
Exactly.
All right, so now what we want to do is to start our concept map.
Exactly. For every one of the activities, at the end we would like to revisit the concept map. So we start with the concept map of just looking at basically what are microbes. So you can put microbes in the center and then go from there to what have we learned so far. And Deanne, what have we learned at this point in time? What do we know more than we knew when we started about microbes?
Well, I'm kind of getting the idea that maybe they're pretty abundant. They're everywhere. From looking at my hands, and also you'll find that when you are able to turn the classroom lights out, that there's little specks of glow dust all over people's clothes, even where they didn't touch or think they touched. They may be a little bit on somebody's face, their clothing, and so I would think that they spread pretty easily.
So that's one thing they can do is they can, with microbes in their concept map, they could go spread easily. So they're all around, or there's many of them. Okay. Another thing that we just discussed, the fact that if we have that many on us and we're relatively well, then they must be helpful. That's another thing we know about microbes at this point.
Right, or at least not harmful. So we don't know for sure. One thing when you're first starting this concept map, students aren't going to know a tremendous amount of information. And one thing that we found that works pretty well is to use sticky notes so that they can move these concepts around as they gain more knowledge throughout the unit. But sticky notes, when you have a lot of students, can add up to a lot of money. So if you don't have that luxury, then you may want to have them work on a concept map. And if they get to a point where they feel like they really like to rearrange it, have them do a revised version, but keep their older versions, because I think that that's really a nice indication of learning.
Oh, also another way that you don't want to forget is to do it all on the computer.
Oh, absolutely.
Definitely do it. They can do it on the computer, and this would be a kind of a way to get them even more involved by designing.
And we know that as soon as we bring in technology, they always love that, and sometimes a lot better at it than we are.
Oh, definitely.
And then, as an extension to this activity, okay, now we know that one of the safety rules, we need to wash our hands. And even though this isn't harmful, so how could I use that as an extension?
Oh, well, I was thinking about the fact that, talk about that you always hear and you see in the restaurants and you hear it everywhere with the doctors, wash your hands, wash your hands, wash your hands. Well, what is effective hand washing? What does it take? How much soap, how much water, how much time? So what about an experiment where they look at the variables of time and amount of soap and water?
Oh, I think that's a great idea. And it also could be whether they used hot water or just cold water.
Or whether they used soap or maybe they didn't use soap.
Maybe not at all. Or maybe even some of the waterless soap. So whatever they can come up with, it's always good to get their minds thinking and let them start thinking about an experiment that would give them some valid results. And you might point out, if you're introducing two variables at a time, that they're not going to be able to tell exactly what it was, whether it was soap or the time, that they've got to be clear about their variables.
So yes, definitely it has to be an organized test. Definitely an organized test on as far as whether it's the time difference or whether it's the soap difference or the no soap difference. So they have some kind of way control and some comparison.
Okay, great. So I think this is a fun way to begin the unit on microbes. Thank you.